Okay, gonna go problems 10 and 11 together in a video. And it's gonna be quick, it's not bad, just some density things. And after this video, I'm going to make one about 2 common mistakes that chemistry students and physics students will sometimes make mathematically. I'll try to highlight them a bit in this video, but I'll make a separate video for them. It'll be short, so make sure to watch that one too. Alright, so we have density problems. Well, what's the formula for density? Density equals mass over volume. I always remember that. And then I fill in where I need to and solve. Don't memorize, oh, I always multiply or I always divide. Fill in what you know. First check units, fill in what you know, and then solve appropriately. Okay. So we're given a mass, this one, and we're given the dimensions of a bar. So it's basically a rectangular prism. We can multiply those together and then we can find the volume of that, since it's a rectangular prism. So grams and cubics, so we're going to fill in here and here, here and here, these two. And so we're going to divide, and so we don't, the density units will be with what those two are on there, or those two M and the V units have on them. You need to make sure they play nice if you're given a density unit and a mass unit, or a density unit and a volume unit, and make sure they play nice, which could be a problem in the bottom one. But we'll get there. We're getting ahead of ourselves. So what is the volume? And centimeters, centimeters, and centimeters all play nice with each other. And so our volume, when we multiply that, is 144 cubic centimeters. Centimeters times centimeters times centimeters is centimeters cubed. So now we can simply fill in D equals 1209.6 grams divided by 144 cubic centimeters. You divide the numbers and you get 8.4, and our units will be grams per centimeters cubed, which you can do that as in kappa G slash CM up caret, which is a shift 6. Now, if this gives you the yellow box of confusion, it says use more digits, you can always add a 0 to that. Okay? All right. Next one. This is similar. It's a density formula, a density problem. Oh, because they give it to us. Yes, and they also give us the density of uranium. So it's a D equals M over V. Okay, look, same thing. We multiply those, multiply this times this times this, and then we fill in and solve for M this time. Well, yes, but we have some issues. For one, these units don't play nice. Centimeters, centimeters, and this is decimeters are down here. Oh, just turn that to centimeters, measure and shot, multiply them. Well, what's your units on your density? Kilograms per cubic meter. Well, cubic meters does not play nice with cubic centimeters. So you have 2 choices. We have actually 3. You could turn the per cubic centimeters to per cubic meters to per cubic centimeters. I wouldn't do that. That's not the easiest choice. You could change this to, you could change this one to centimeters, multiply them, turn the decimeters to centimeters, multiply them, and then turn cubic centimeters to cubic meters. Not what I would do either, but you could. I would turn these all to cubic meters, then multiply them, then fill into the formula. That was just what I would do. So 1 cubic centimeter, won't you pause 1 centimeter, pause right now and convert them to cubic meters. Okay, I am going to convert these. Centimeters, there is 100 centimeters in 1 cubic meter, and there are 10 decimeters in 1 cubic meter. Well, this conversion would make it 0.01 meters, this is 0.04 meters, and this one is 0.08 meters. So now our volume would be 0.08 times 0.0, maybe I'll use parentheses, 4 times 0.01. And when you multiply them, oh, that's meters times meters times meters. And so our volume ends up being, I did not do that, hold on, 0.01 times 0.04 times 0.08, and it is 3.2 times 10 to the negative fifth cubic meters. Okay, now we're ready to fill in. 1.8 filling into the density times 10 to the fourth kilograms per cubic meter equals m over our volume of 3.2 times 10 to the negative fifth cubic meters. So where is our variable? Our variable, I'll draw another quick color here. And our variable is right here, right? It's this. Well, how do you solve? What is being done to it? Well, you're dividing it by this. Okay, how do you want to do that? Multiplication. So you will multiply both sides by this number here, right? But be careful, it's in scientific notation. Always when you're multiplying, dividing, and you have a scientific notation quantity, please package it in parentheses. And when you do it, it wouldn't hurt you in this one to do it, but there are future ones that will. So when we multiply this, we get an m, and the meters will end up canceling out as you multiply it over here, and you're left with kilograms for your units on mass. And so when we do that, I get 0.6064 kilograms. All right, give that a try. Go ahead and shoot me an email if you have questions.